This is the Amp Hour Podcast. Released January 24th, 2021. Episode 527. Measuring Current with Matt Liberty. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Matt Liberty, the creator of Joule.
Hey, Matt, how are you?
Doing great. How about you, Chris?
I'm real great. I'm excited to talk about the Joule Scope. In fact, this is really good timing because I was going to call you anyways. I have a lot of questions about Joule Scope. I have some testing coming up from the board I've been working on, and I wanted to measure some low currents. And I was like, well, yeah, I'm going to call Matt anyways. So let's get him on the Amp Hour. And of course, I want to hear about this. And of course, well, not of course on this one, but Matt has also been documenting a lot of his product progress on the Contextual Electronics Consulting Forum, and that has been really useful. So let's start with, what is the Joule Scope?
Well, the Joule is a product that I created to measure really high dynamic range currents and voltage so that you could determine the power consumption and energy consumption of your product. So as you're designing a project, you have this test instrument that is Joule in between your normal power supply and your device, and it tells you everything you need to know about how your device is functioning, both as like a multimeter, but also as a waveform viewer over time for your current, power, voltage, and energy and charge as well.
And why is that tough? I think that whenever I tell people about the Joule Scope or similar instruments, they're like, well, I'll just use my DMM or something like that. So, or I'll use my scope. What is the actual hard part there?
Well, you certainly can. A lot of people get started out by trying to use their DMM or an oscilloscope with a shunt resistor. The problem with modern electronics, though, is that we typically have a very high normal operating current. So you turn on a radio or blink some LEDs, and then in order to manage power, it goes to sleep. And the difference between that active current, which is typically milliamps or even amps, then drops all the way down to microamps. And that huge range is very difficult to measure. So if you think about number of bits and precision, it way exceeds what you can normally afford as far as an ADC.
Yeah, and I think the thing I always think about is like, I used to work on electrometers when I was at Keithley, and so that's like really, really small currents. But the way that it would do it is like literally they would switch. It was like the topology is really simple. It's actually just like it's an inverting amplifier effectively, and you just switch in larger and larger resistors. And it's like in an electrometer, it's literally huge resistors, like tera ohm resistors, and then you switch them in with these monster relays as well. And I always think about that going from like super, super small currents like nanoamps up to like an amp. Well, that feedback resistor is completely different in terms of construction, in terms of its actual resistance, other, parasitics and stuff like that. And it's a nightmare to deal with. It's all in the switching, it feels like.
Yeah, and the thing about it is it sounds really simple because it's just, with Joule, it's a shunt ammeter, which means it's doing exactly what you're saying. It's using a resistor and then using the voltage over that resistor to estimate current, so Ohm's law. And as you go from those very high currents, it's using like a 0.01 ohm resistor. And then if you go all the way down to the lowest, it has a 1K resistor for the most sensitive range. But again, switching through all of those is not as easy as you sound, especially when you want it to be accurate. You want to have low burden voltage. So that's the voltage over that resistor. The higher it is, the more problems that you have with your target system. You can cause brownout and your target can misbehave. And typical DMMs can have burden voltage ratings of like 0.6 volts or even higher, which if you're talking about 3.3 volts or even 2.5 or 1.8 volt supplies to your board, that's crazy.
Yeah, that's yeah, you're gonna have a bad time.
Exactly. Bad things happen. So Joule is designed to make sure that is always very small, 20 millivolts across the shunt resistor, and still have the full dynamic range by switching seamlessly. So it ends up being a very difficult problem when you're going through that whole range. And this is something that I've faced throughout my career, and there just really wasn't an easy way to do it. So I ended up taking some of my consulting time, spending it on my own product, and then developing Joule so that I'd solve my own problem, but also help a lot of other people that are out there that are designing products have quantifiable ways of measuring what they care about.
And now you're doing it full time.
I
So
am.
support Mad, buy a Joule scope, folks. Okay, well, let's talk about how I'm going to try and paint a picture for what I want to do here, and maybe then just I think it's actually going to be really simple in terms of like what the Joule scope offers, but maybe just to help visualize what we're going to be looking at here. I'll explain the problem. We can talk through some of the measurement solutions. I'm going to get a little bit of benefit here. Yes, of course, folks, I'm going to be a little selfish with my benefit of having the creator of the device explain it to me, but hopefully you benefit from it as well. So I have this board, the ABC board, and the big thing is it's got a cellular modem, and which takes a ton of current, so like upwards of an amp or two, at peak times, and then it's all being controlled with an NRF52, which is a Cortex M4 Bluetooth modem, but it's got a lot of sleep modes and lots of very very low sleep currents. And so what I want to do is measure each of the different phases there, that each of the different life cycle phases of modem on in steady state, modem on in transmitting, modem in sleep state, modem completely shut off, and then NRF52 in normal operating state, and NRF52 with everything shut off except maybe like a real time clock. So
Mhm.
how do I go about like starting to plug all this stuff together?
Well, it depends upon where you're starting from. So a lot of times in the design cycle, you start by planning, right? So it sounds like you're a little beyond that right now.
Whoa, I don't do that. Yeah. Yeah.
Yeah, but I mean, what you've talked about are several different states that your system's in, right?
Yep.
So you can kind of estimate just from the design phase of what you think it should be spending as far as current or energy power in each of those modes. And then you know how long each of those modes are typically on, and you can kind of work up a budget. Ideally, you have a budget so that you just don't start measuring things and say, yeah, that looks good. You want to ideally check against what you think is right.
Got it.
It helps make sense of the situation, right? So if you think you're supposed to be in your low current and it's supposed to draw 10 microamps and you're finding that it draws 20 microamps, if you hadn't done the budget, you might say, yeah, that's probably good. But if
Right.
you have done your
Right.
budget, you now know that there's probably a 10K resistor, a 100K resistor that is partially on or something like that. So you can use the Joule scope to just measure your device once it's built, and that allows you to check it. So you can, depending upon your system, there's lots of ways of going about it, right? But you can connect this up to your device, and if you know the state of your device and can actually put it into a mode, that's one way to actually confirm things. The other is that Joule Scope has two general purpose inputs, so a lot of times you can toggle a GPIO line, and that will tell you when you look at the Joule Scope waveform which state your device is in. So from that, you can actually chop out that area you care about and compute either the charge or the energy that you spent in that state. And then you can build up your same model from that. You know how many times you're going to be in a state per unit times per day, per hour, whatever you care about.
Yep.
You can then work your model from there.
Yeah, that's a great point. And I think the idea of the GPIO is good too, because if you think about all these different operating modes, it's all been driven by firmware. And so when I go to transmit, an MQTT packet over cellular, that's going to be some subroutine that's running, and I can just throw in a GPIO toggle in there as well, maybe even just as a debug thing. And then now that GPIO toggle's high, and the Joule scope knows, hey, Chris is about to try and throw some stuff to the network, and see what that looks like.
Exactly. Yeah, and you can just drop in the JewelScope software. You can drop in two dual markers, and one on each end of that transition, and it will tell you essentially what your energy or charge is.
Okay. And then so in terms of the actual like plugging in, I mean, is it just going to be USB? Does it act as a battery? Like what is the actual, I mean, so I know that I'm going to try and measure current, but I have to try and measure current as some kind of input. So what does that usually look like? Like how am I interfacing the Joule scope to the product normally?
Right. So JewelScope sits just in the middle of what your normal supply would be and your target board. So JewelScope is just an instrument. So it's not actually a power supply. And it has two inputs. It has an in positive and in negative that go to your battery or bench supply or wall wart, whatever you normally use. And then on the other side, it has out plus and out minus that just go to your target.
Yeah.
JewelScope comes with a banana jack by default, but it has different front panels, and you can even design your own. It's open source, and you can have a USB one that we offer off the shelf. We have binding posts, and then people have created a few other ones that are out there on the web.
Oh, cool. Like what are some of the examples of the like the weird ones?
Well, there's one general one. I know that there's one that has just headers for in and out.
Yep.
I have one that's unfortunately that was given to me, but was never released as open source. That's USB 3, and it mostly works. USB 3 super speed. But
Yeah.
when you start talking about interrupting a super speed bus, that signaling gets a little dodgy unless you have a repeater, and that board does not have a repeater.
Got it. Yeah.
I know Colin O'Flynn made one that has party time for the LED that hooks up to his stuff.
Great job, Colin. Great
Yeah.
job. Doing the Lord's work. That's awesome. Yeah. Okay. Cool. Yeah. That and so in my case, I would say that the way that I'm going to probably hook this up then is I'm going to take one of the leads to really cut down on any kind of outside weirdness. So like if I could pass through the USB-C that's going to this board, but I think it'd probably be easier to just do the battery and just interrupt the battery like positive line and pass that through the Joule scope, because then there's no possibility that any of the USB is going to charge the battery because of like trickle charging or something like that. It's just coming straight off the battery through the PMIC rather into the board. I think that would probably be the simplest.
Yeah, that works. And you can also use Joule Scope to measure the charge and discharge cycles of your system.
Mm-hmm.
It's not totally symmetric, but it's symmetric enough that it can measure battery discharge and recharge.
Mm. And how do you and that would be like if it was going through the USB or at the actual battery itself?
It's up to you either way.
Oh, okay. Cool. Yeah. Great. Okay, so now I'm gonna go trigger a measurement, and I look at this thing, and I remember when Dave did a review of the Joule scope, he was a little confounded by it, but I didn't find it that confusing. What do people expect to see when they're starting to actually look at measurements?
It varies. So I've had a number of different customers. Some are very, into this. They know exactly what they're looking for. They may have used high-end equipment that does similar things, so they're very adept at it. So they just want to get to see the waveform.
Mm-hmm.
JewelScope has that waveform view, but when you start the software by default, it comes up in a multimeter view because a lot of people are very familiar with multimeters, even more so than like a waveform and oscilloscope. And it will just update every half second, 2 hertz, and display. If that all you want is just what's going on in human time scale, that's a great way to do
Mm-hmm.
it.
Yeah, right. So you're not going to catch like the super peaky stuff, like a huge slug of current or anything, but you'll probably see steady state and maybe a little bit of variations because of things asking for more current at any given time.
Exactly. Yeah. And as a developer, a lot of times you'll want to see, oh, I shortened this routine by 10 milliseconds or 3 milliseconds, and I expect to see my power go down. And JewelScope in the waveform view can do that, and you can see it and actually quantify it. Because JewelScope's sampling at 2 million times a second, it makes it really easy to see. But if all you care about is long-term energy consumption, and this happens typically after you've done product design, right? You want to actually now see how your device is going to behave in the field, how it's going to
Right. How long will it
long
last
term.
when it's not transmitting, or if it's in different modes and trying to do power save or whatever?
Exactly. And you don't care about the detailed waveform at the time. You care about collecting hours, days, months worth of data. JewelScope is able of doing that too with either through the UI or through scripts.
Got it. Cool. What so I know the NRF52 is like a it's low power, but
Mm-hmm.
it's not going to be like the sipping current. What is like the low end? What's the kind of the lowest amount of current that you'd expect I could resolve with the Joule scope?
Well, our minimum resolution goes down to about 1 nanoamp.
Okay. And so that'd be like the end of that's like the least significant bit type of thing, right? Like the
Correct.
furthest digit to the right. Yeah.
Yeah, so that's its resolution. The actual accuracy in that range is 30 nanoamps, plus or minus 30 nanoamps.
Okay.
There's a difference between resolution, which is the smallest change it can detect, versus accuracy. And this happens with every single test instrument. This is not unique to JewelScope. So a lot of times people get confused by that. of what is the accuracy versus what can I actually see a change. And sometimes you
Hmm.
just care about a change if you make a small amount of variation, but you really don't care about that. A Joule scope is more than accurate enough for that. So if you want to measure your sleep mode current and it goes down to a microamp, or even less, 100 nanoamps, Joule scope's able to resolve that and measure it accurately.
Okay, that's great. Yeah, I always point people at the bullseye
Hmm.
example for like accuracy, precision, and resolution. I guess
Hmm.
resolution is usually not on there. At least accuracy versus precision. Maybe there's a third one on there, but yeah, it'd be like I think that I always feel like that was the one that kind of helped me understand it of like throwing darts at a dartboard, and accuracy is like all the darts are centered around the bullseye. Precision is like all the darts are centered in one area, but not necessarily the bullseye.
Hmm.
And then I don't remember the last one was. It was just like maybe resolution was like two darts next to each other, and you can tell it's two darts instead of one. I don't know. So
It's how blurry your eyesight is, I guess.
that's right, right. It's worse every day. Worse every
Right.
day. Okay, cool. So, what are some pitfalls? Like, what should I expect to run into?
Well, the biggest pitfalls actually are not with just the measurement, but it's more with just understanding your design. When you actually start measuring, it's in any complicated system, it's hard to separate things out. So if you
Mm,
have different microcontrollers, different subsystems, and it's not behaving like you expect. Let's say it's consuming more current than you think, which is the typical case.
yeah.
Tracing tracing that down is not something that any instrument's going to help you with, at
Right.
least on your design for your board. And it's really easy to make very simple mistakes like back powering a pin. You shut down
Yep.
a subsystem and now you're leaking a little current through a pin. You have a resistor that's slightly turned on or a pull up that is engaged. Lots of things like that that can happen at the hardware level that it's really up to you to track down. But Joule Scope and other equipment that's like Joule Scope gives you the ability to at least see and quantify that value. But it's really up to you to figure out what's going on. And there's a lot of things you have to check to make sure you've done them right when you're talking about really low power design.
I mean, what is the expected standard these days? I guess I always like see products being like 10 years on a coin cell or 10 years on this thing, and I'm just like, okay, well, that is like I guess, kind of a soft goal, but it's not well quantified. So, like, what do you expect modern low power systems to be able to do relatively? I mean, like,
Right.
again, it's going to be soft, but what would, yeah.
Yeah, I mean that's the thing that low power means different things to different people. So if you're in Linux and you're running something that is
Yeah.
low power,
Only 150 milliamps.
right. I mean, my mobile phone, even if I have it in sleep mode, lasts for what, 2 days maybe.
Yeah.
So that is a device where power is actually very important. It's just different from a sensor that's out there that someone has to drive to a remote location to upgrade the battery or replace the battery. So the products really determine the cost and benefit of battery life. So if you have a battery and it's something that you can put on your charging stand every day, like a mobile phone, then it's not so bad. You need it to last for the day. If it's something that is out in the field, let's say the whole Internet of Things push, where you have battery powered things everywhere. Well, if you have 1,000 things and the battery lasts for a year, on average, you're going to be replacing 3 batteries a day, right?
That's right. Yeah. Yeah. Your
So
technicians are going to hate you.
exactly. Well, there's a cost to it, right? Maybe,
Yeah.
maybe there's some applications where that cost is justified, and that's the best you can get.
Yeah. Or if things are like coming back through for routine maintenance, anyways, it's like, okay, well, now we've got a system for doing that sort of thing.
Right. And this is the thing with Internet of Things. What is the Internet of Things? What battery life is appropriate? And it really depends upon the thing. But yeah, a lot of people are targeting 1 to 2 year battery lives. Some things, up to 10. I haven't heard much that goes beyond that. And there's a lot of challenges, even with just battery self discharge. Once you get to that type of duration,
Yeah.
it's not even about your design necessarily. It's about selecting a battery that can even last that long on its own.
Right. Commissioning systems that can last for 20, 25 years. So I was just actually just looking at some of my old stuff that I was replacing old like industrial systems and power plants, and those are like 30-year lifespans. And it's like, okay, 30-year lifespans, and they're supposed to work for 30 years, but they're not going without like monitoring, without like technicians checking in on things. Like, yeah, the board itself is supposed to last 30 years, but like, they're not powered from batteries. It's like they're like these big beefy components that are just super over spec'd. So yeah, I think it does require an overall system view in order to have a realistic viewpoint on everything.
Yeah, but that said, we're at a time in history right now where low power design is easier than it's ever been. There are a lot of low power microcontrollers. The NRF family that you're talking about is definitely one of them.
Hmm.
Ambic, is another company out there that's really focused on low power. But even the normal chip manufacturers, the STs and NXPs of the world, have a great portfolio of low power devices. So
Yeah.
we have the ability with microcontrollers now to go out and design something that has a 10 microamp sleep current or 20 microamp sleep current without too much real hard design work.
Well, hell, let's pull a little the current news into the fray too. Even Raspberry Pi is getting into the microcontroller game. So yeah, microcontrollers everywhere apparently.
Definitely, yeah, that's really cool with the Raspberry Pi thing. There, the PIO
Yeah,
stuff looks really cool.
yeah,
Yeah, the whole microcontroller market right now is such a diverse, and so you have lots of choices about everything from lots of processing down to little teeny low power stuff. It enables a whole bunch of designs.
yeah. I mean, personally, I look at it. Again, selfishly, I look at it and it's like there's a lot of work to be done there too. Like obviously, you need to be able to write firmware, but also then do things like we're talking about here, optimizing low power design and like understanding segmenting off design and being able to turn power on and off external to a chip, internal to a chip, and there's just a lot of optimization that can be done, and at the same time things are moving really quickly outside of any one project.
Yeah, definitely. And there's some projects that battery life or energy consumption is a primary concern.
Yeah.
It's part of what makes the product, right? And there's some things where it's just kind of a nice to have. So if you think about a kid's toy, it's nice to have long battery life, but is anyone going to really complain too much if it's, $10? Would they buy it if it had to be $50 and you got twice the battery life? Maybe not,
Right.
because, having battery life and being really miserly on energy consumption oftentimes requires better engineering
Hmm.
and better component selection, and that costs money.
I've seen my nephews, their toys, and they're loud and blinky and whatever. I feel like the short battery life is one of the benefits. Oh, sorry, the battery's dead. guess guess that police car is not going to be making that really loud siren noise anymore, kids.
We're fresh out of batteries.
Yep. Oh, sorry. I guess I shouldn't have thrown all those batteries in the trash right before I knew that thing was dying.
Oh, yes.
Yeah. Cool. Well, I mean, so it seems like it's a pretty straightforward process on the actual using of the Joule scope. I mean, have you seen them being used in unexpected ways from when you started designing this thing?
Yeah, there have been a few applications that have been interesting. So people have tried to use it more as an electrometer, going back to your history, because those devices are extremely expensive and Joule Scope is not.
That's
So
right. Yeah, I think the Joule scope's about a sixth or a tenth the price rather of an electrometer.
yeah, even the starting, baseline stuff. So
Yeah.
I've had a few people use it that way, and it within reason, it does the job. I mean, if you're trying to measure picoamps or femtoamps, you're out of luck with Joule Scope. But
Right.
that's probably one of the more interesting. I've had some people use it for more sciencey based things, which I really didn't intend. The target market was really people doing product design or their own microcontroller based designs. But people have used it for other things. It's also been picked up for a lot of testing. So the QA departments for some larger companies have started using it to qualify, not just the single unit during development, but across their units as they're preparing them for deployment. And this is
Oh.
true of any product. You want to make sure that it works before it goes out. And power, if that's one of the things you care about, it's one of the things you have to measure.
So people are doing that at like as like a factory test like calibration type step. They're making sure it's low power enough.
There's that. That actually wasn't what I was talking about with this one, but yes, but, there's also the QA side, the quality assurance. So as it moves from engineering before production, there are companies that'll put 50 or even 100 units through their soak testing, usually over temperature, environment conditions, temperature, humidity, voltage, and they'll be measuring power and making sure the device continues to function through that whole time.
I guess I wouldn't have expected like I mean I expect component drift to impact things, but I guess I didn't think about it in terms of leakage currents and just battery life and things like that. What is the relative complexity of these types of things that are doing that? Is it like tiny like sensor node type of thing?
Yeah, so if you're designing a little IoT node or a module, like an RF module, and you spec it over, let's say the industrial temperature range, full industrial, so minus 40 to 125, your current consumption of your device is going to vary dramatically. So at 125 degrees, it's going to spend a lot more energy because it's just not as efficient at that temperature.
I feel like my inner industrial guy is like, wait, no, I can't afford that. That's automotive temperature. Isn't industrial 85? I thought industrial is 85, automotive is 125.
Yeah, automotive's 125. Yeah,
Yeah,
85
okay.
is industrial. Yep.
Yeah. I can't do 125, man. I don't know what the hell to do up at that range. Like, man, it's like boiling, Like that's crazy.
Yeah, a lot of parts now on the microcontroller side are all rated out to that.
Oh yeah, I
So,
mean, like
yeah,
if you're gonna have to sell into the automotive market anyways, I guess they probably can't get the margin to do that extra testing, so they're just like, "Yep, we tested at 125."
yep, yep. And if you work out to that, it's even better, right? You know that you're going to easily pass at
Yeah, yeah,
85, right?
yep, totally. Bathtub curves all day. That's cool. So, and are people using this? So you kind of what it kind of sounded like you were talking about, but maybe I'm putting words in your mouth here. Is anyone using this in like a continuous integration type of setup or scripting type of setup?
Well, definitely scripting. So, JuleScope itself, it has a full Python library on the host side that's open source.
Cool.
Actually, two parts. There's a Python driver essentially for the JuleScope and a user interface for it that are two separate repos. And there's also an examples library that uses the driver and does a whole bunch of different things. So it gives you examples for how to set things up and capture data and record data. And I know people have used that for their own automated testing. So one of the choices that I had making JuleScope is open source versus closed source versus sharing. And where's that right balance? The test instrument industry is often very closed.
Yeah.
We have Skippy and the way of hooking up into National Instruments stuff.
GPIB, HPIB.
Yeah, the GPIB and LXI is the other one,
Yeah,
and
yeah,
yeah,
yeah.
so all these different standards. But when you talk about streaming data, they're all pretty poor, right?
They're
They
all
were
pretty written in the 80s.
exactly.
Well, LXI is newer, I should say. That is
It
that is
is.
late 90s, early 2000s, I think,
It
right?
is. Yeah, so it does streaming data somewhat.
Yeah.
But a lot of the test instrument mentality is that you capture a buffer, then transfer the buffer, capture a buffer,
Got it.
transfer buffer. Whereas JuleScope, because it's always measuring power, so it has to always be on. It can't miss a part. So it's a fully continuous streaming segment that never has a gap. There's no window like you think of with an oscilloscope. So because of
Mhm.
that, we just ended up implementing our own Python library that allows you to hook it up to pretty much anything you want. So you can
Mhm.
write a little Python script, and it's just another instrument that you can script in Python.
Yeah, it kind of sounds like that's kind of how the HackRF does it as well, where so
Mhm.
Osman and crew, the Great Scott crew, they basically pipe all the data back, and then they lean on the computer to do more of the actual heavy lifting. Is it similar for JuleScope?
It is, yeah, and there's a whole class of USB connected devices. They're one, the Salier Logic stuff is another one, right? So they do the exact same thing. They just ship all the data back over to the host computer and do whatever they need to over there.
Right. And I think that cuts. So, like, that's a great example with the scope. I think a traditional oscilloscope, like, basically there's an embedded computer in there. There's a full computer in there, right? It's just like, yeah, because it's capturing that data, it needs to display that data. But now we have these smaller devices, headless, effectively. So all of the everything else is now pushed to the computer, which is already doing the everything else, right? It's a general purpose machine, anyways.
Yeah, exactly.
Yeah, cool. So, I mean, are there are there risks with that though, like streaming missing packets or anything like that? I mean, with streaming versus buffering.
Yeah, definitely. So USB is a notorious protocol for being a little flaky. So it was designed to be low cost and move data reliably, but moving data reliably with a deadline is not something that it's ever done that great. So there is an isochronous mode in USB,
A what mode?
isochronous or isochronous, depending upon your pronunciation. So not it means that you end up budgeting a certain amount of the bandwidth of USB in this mode for your device.
Is that starting with an A, like asynchronous, or
No,
isochronous?
yeah.
Okay. My brain was just like, is he saying it wrong? Like,
I might be. No.
no. I mean, so it actually starts with a isochronous. Okay, I'll have to look that up. I've never heard of that before. Okay, so
Yeah,
keep
so
going.
USB as a protocol is actually really interesting. They have a few different ways of moving data. Bulk is what most people are familiar with. If you have a mass storage device, it's using this and it does guaranteed delivery. So if there's
Hmm.
a problem over USB, it just tries again. Then there is your interrupt mode coming in,
Hmm.
which if you have data like from a mouse or something, it can periodically tell your computer, "Hey, pay attention to me." Uh, then there's your control endpoint, which is the basic of all before all of this of just talking to that device over control. And then there's isochronous, which is having a stream of data where you have dedicated bandwidth. The problem with isochronous is if you lose something, you lose it. The problem with bulk is if you lose something, it's going to retry, but may not retry fast enough, and it doesn't guarantee bandwidth. So there's no nice thing in USB to high speed, at least, that allows you to have something that is somewhat guaranteed bandwidth and guaranteed ish delivery that makes sense, right? So USB is not a great protocol for streaming, but it's not terrible. It's pretty reliable, and as long as you follow some basic guidelines and don't spend too much band or put too much bandwidth over your USB bus, then you'll be okay.
Right. So don't have like four webcams plugged into your computer at the same time and all running at the same
Exactly.
time as Joule scope, something like that.
Exactly. Or
Yeah.
don't plug four Joule scopes into the same USB root hub
Right.
because
Right.
it
Yeah.
won't work.
Exactly. Yeah.
This is something that people have tried to do, and you have a limit to how many Joule scopes you can have at the full data rate going back to your single root hub.
Let's talk about the. So you mentioned low cost from the beginning. What are you up against here? What else is kind of in the marketplace?
There are a few other things that are out there. The biggest competitors are ones that cost 10 times the price, really. And that's what I wanted to compete against. And then on the
Hmm.
lower end, there are things, starting from, the microcurrent, which
Hmm.
your co-host designed a number of years ago.
That's right. Yeah.
Yeah, so there, and then there's the current Ranger, which was released 2 or 3 years ago, but it does similar type of things but slower, and has some issues. And then at the low end, there's another product that came out not too long ago called Nano Ranger, I think, and
Hmm.
it's a little slow, but it's more of the multimeter style thing. And then you hop up. There's a product that's in a similar price range as JewelScope that is called the OD Arc. They have great software. Their hardware, JewelScope outperforms it by quite a bit. And then there's a small Indian company that has a few products that are on the market, but I don't know too much about them.
The one that I'm actually interested in too is I keep seeing all these like chip manufacturers doing it too. So like
Hmm.
mentioning Nordic like started like being like, well, I think it's Nordic,
Hmm.
but it's basically like on a dev board. They have these current monitoring kind of situations. I have not tried them yet, but it seems like that's something that they're trying to do is like value add from chip manufacturers as well.
Right. Yeah. So Nordic has I think it's the Power Profiler Kit 2 now that just came
Yeah,
out.
that's it. Yeah.
Yeah. And it's like $100 thing. And it's 20% accurate. So, it gives you a relative sense of things, but, it's 20% accurate. It's better than nothing, but, if you actually want to measure something with, 0.25% accuracy, you step up to JewelScope.
Yeah. Yeah. And so I guess that is kind of comes down to like, what is so the value add, it sounds like so far, hearing this stuff is software layer for sure, and all this, but then accuracy. So just like the base level components, the calibration, all the other things. What else is in there? Like, what is it? User experience? Is it, like maybe comparing just at the higher end too? Like, so you're kind of straddling the two, between this, like a Keysight, whatever, and something at the very, very bottom, like a Nano Ranger. And so like, is it just lower cost but same accuracy when you're playing against the big guys like Keysights?
Yeah, I mean the goal of JewelScope is to be every bit as accurate as those $10,000 things that start at $10,000.
Yeah, before add-ons. Don't forget the add-ons.
Exactly, before you add the board that you need.
Yeah,
Yeah, so
yeah.
and I've gotten a lot of feedback from people that have those pieces of equipment and have used JewelScope, and those pieces of equipment end up sitting in the lab, and JewelScope sits on their desk and gets used. So the whole idea with JewelScope is to be very simple to use, and it's, I'm not the first person to create an instrument with that type of mentality. The Salier guys did a great job. They've done an awesome job. So there's a lot of similarities between what I've tried to do with JewelScope as to what they did with the logic analyzer market.
There's certain things. So Dave and I have talked on the show before about like wanting to have an oscilloscope. I feel like that's a very certain thing at the bench. Being
Mm-hmm.
tied to a computer, it's like, it's not undoable. I use like the analog discovery too for stuff when I'm on the road or if I'm in a pinch, and like it's not terrible actually. Using a computer based type of thing there. But that's because I'm so like ingratiated to a oscilloscope and the knobs and like the tactile feedback and all that stuff. When you start getting into like things that are naturally scripted anyways, if you're running a script to tell when a microcontroller is in a certain mode, it's like, all right, well, why not just use a thing that's plugged into the computer that's running the script as well? So I just feel like some of that stuff is natural.
Oh, definitely. And I think there is a difference between people that grew up with knobs and dials and people that are coming up and just seeing these devices like the Saleae Logic that don't have anything. I mean, really,
Yeah.
they have nothing. There's no buttons, no switches, no barely one LED, right?
Click and drag, click and drag. It's like,
Exactly.
yeah.
And for me, I have, and I think this is true of a lot of engineers now. You have a computer at your desk, you have a computer in the lab. Um,
Hmm.
you don't have to go far from a computer, so just plugging something in is somewhat natural, and you get a lot better experience. At least in
Hmm.
my opinion. So the knobs and clicky things, yeah, they scale to a point, but eventually they just get hard to use. And the goal is not to have lots of knobs and dials and clicky things. The goal is to have none, ideally, and just have it
Yeah,
work,
right. Right.
right?
To just give you the answer, right? That's the best case scenario.
And that's really what I'm focusing on and trying to get to with JewelScope. And we're not all the way there yet, but it's most of the way.
So what I'm hearing here, Matt, is that you're implementing an AI that's going to be like, hello, Matt. Your reading is 4.4 nanoamps.
Right, right.
Yeah. You should think of removing that 10K pull-up resistor.
Now, it would be pretty cool if it could tell you that.
Yeah, yeah. Yeah, I mean, that would be great. That I would be less interested because I think I wouldn't have a job anymore. So a little less interested, but lower cost for the clients. So that's good.
Oh, you'd still have a job. There'd just be other things you'd be doing. You wouldn't have to worry about that 10K resistor anymore. You have to be worrying about the parts selection and if the parts are all working together.
Right, I'd just be writing the code and everybody would be happy with that, I'm sure. Well, let's hop to the code real quick. So I mean, interacting. So you have a firmware background, I should say, as well. I mean, like you've been doing firmware a long time. I don't know if you'd refer to yourself more as a firmware engineer, but I've kind of thought about that from the fact of where you've started stuff. Is it an accurate characterization of you?
I'm kind of all over the place. So I started out, graduated with an electrical engineering degree,
Mm-hmm.
and did a lot of my initial work with some circuit board design, but a lot of FPGA design early in my career. Then I went back to doing more algorithms and firmware and inertial sensing stuff. And then for my consulting jobs, it's mostly been firmware. So over the last, a little over 10 years now, I've been mostly focused on firmware.
Yeah. Yeah, I think that's probably because I met you because of consulting and things like that, and hearing you on Embedded FM, which is another good episode. I'll link people into as well. I guess that probably the Embedded FM thing locked me, and I'm like, oh well, yeah, Matt's on Embedded FM. He's a firmware person.
You're on it.
That's a good point. I had not thought about that. So now we're doing stuff with firmware. How do you actually start to? So you have a Joule scope in front of you. You start to see some spikes. You've verified it's maybe not pull-ups. It's not leaky parts on the board or anything like that. What do you start to do when you are trying to improve power profiles in the firmware side of things?
Right. So, I mean, the first step is to figure out where your power is going. And it depending upon what you're tracking, that can be easy or hard. So, if you know that you're only making one change and you see your power change, that's easy. But a lot of
Yeah.
times it's actually not quite that simple because you have a part of your firmware that goes and does a bunch that turns on a radio, it turns on this subsystem, clocking, turns on this other peripheral. So, it just if in your normal software, it's hard to figure out what is consuming what
Mm.
amount of power.
Okay, so maybe I can make it selfish again. So I'm using
Hmm.
Zephyr, and it's a real-time operating system, and so there's
Hmm.
going to be like a sleepy mode, and there's going to be a a MQTT, all these different threads that are happening. Is it harder or easier to do it when you're using an RTOS and trying to profile that kind of power?
Well, if you're just trying to profile it and not trying to figure out where it's really going, it's relatively easy, right? So you can just see where your code is spending its time, during this segment that you care about, like this MQTT message send, right? So you
Hmm.
say start of message, end of message, and then great. If that meets your goal, then you're fine. Now, the hard part is when it doesn't, because now you have
Mm.
to figure out where you should be spending your time, right? You don't want to spend your time optimizing 1% of the current consumption when there's this low hanging fruit that's consuming half of it. So optimizing that half is going to be way better return than spending your time on that 1%, where even if you optimize it, you're still consuming 99% of your power,
Got
right?
it. Yeah.
So finding the things that are consuming power can be a little more exploratory typically. So you take your firmware and you chop out something. So instead of turning on the sensor, you just make up a message, right? So now you know how much your sensor contributed.
Ah, okay. So kind of like profiling one thing at a time and building up like a characteristic curve of how much power a certain task takes.
Exactly. In the real world, you want to divide and conquer, right? So you want to figure out, where things are going. So a common way of doing that is just don't do something and see the difference, right?
Looks like you're taking a lot of power. Have you thought about not doing that?
Works for the short term, but not the long
Yeah,
term, right? Yeah.
yeah.
You eventually have to put it back in and hopefully
That's right.
optimize.
That's
But
right. Right. Right.
yeah, and the other part that gets really hard is the sleep currents,
Mm.
because everything's shut off. And unless you've built features into your design to actually physically disable things,
Hmm.
disconnect them electrically,
Yeah, power
then
switches and things like that.
exactly, yeah, then you really don't know where things are going unless you start doing that manually.
And by manually, I mean getting out a hot air pencil and taking parts off the board.
Yeah, well, even before you do that, one easy thing that's a really simple trick is you just go with a multimeter and measure the voltage across every resistor in your sleep mode.
Yeah,
There,
that's
there
good.
should be
Yep.
no voltage across a resistor. If there's voltage across a resistor, you're wasting power. So it's a really easy check. Capacitors have voltage across them for your bypass caps. Resistors don't.
Yep. Great. That's yeah, and you can just start multiplying or dividing by resistances, right? So get your currents and start to figure out what the hell's going on there. I think yeah, like especially for pull-up resistors, that's a great one.
Yeah, and if you have any pull-up resistors that are active in your sleep mode and you're thinking about battery life in terms of years, you're out of luck, right? You can't be powering any type of resistor in a sleep mode.
So it sounds like then you have to take a step back into the system design side of things. So when you're designing systems that are super low power now, what do you usually prescribe for doing that? Are you putting in a separate pull-up like rail that you can shut off in a sleep mode?
Yeah, so if you have pull-ups that normally need to be activated, you have to make sure that they're off. So there's a few ways of doing that. One, they just are pulled to ground. A lot of historically pull-ups were to VCC, right? Your power rail. That's just really bad when you start talking about low power design, because that means when your chip power is down, unless you can keep that pin high, it's consuming current. Now, a lot of times, if you power down a segment and you have a pull up on a line, you're now back powering something through that resistor. So that's
Yep.
also bad. So pull ups in general are just a challenge for low power design. So yes, you have to figure out some way, if they're
You heard it here first, folks. Matt Liberty hates I squared C. He just hates it.
yeah, you have to turn them off. So basically, you have to shut off power to the I squared C bus, or have all the devices still remain powered but in a low power state.
So like an actual, so you send a command over I squared C, and there's maybe some internal register that puts it into a mode that's low power or something like that.
Yeah, so a lot of things like accelerometers and sensors will have a very low power mode that they can
Hmm.
go into. But
Yeah.
for if you're talking to a microcontroller over I squared C, it doesn't necessarily have that. You may want to shut that entire subsystem off, which means you now have some load switch that goes to that target part of the design, and you shut the whole
Hmm.
thing down. But now you have to worry about back powering it. And
Yep,
back
definitely have
just
done that one. Yeah,
yeah, and
it's a stinker.
yeah, I don't think I explained. So back powering. So if you have a IC that's turned off and you have any type of thing driving a high level, a lot of times what happens is it will go into the chip, and the chip has protection diodes on every IO. And what happens is that goes in and actually powers up slightly the power rail inside the chip.
Right.
That's what back powering means for everyone.
Right. Yeah, because basically the sensor that's out there hanging off this line, its power's been cut off, but it's still quote unquote asking for power, and so it's going to try and get it from somewhere. In this case, it's the diode on the other side of things.
Exactly. Yeah. And that's a
Yeah.
big problem because now your resistor is dissipating that energy and your chip is now in an undefined state where who knows what it's doing when it's
Yeah.
partially powered.
Right. Then you start doing silly things like putting your or reconfiguring your pins before you go into sleep mode on the micro, and then that's also not good. Not good.
It's not bad. It's kind of par for the course. It's what you have to
Yeah.
do in order
Yeah.
to get to those extremely low currents. So you do need to think about the voltage level for each pin, and most ICs these days now have recommendations for the lowest power configuration for those pins. Usually it's ground, right? So
Yeah.
usually making them an output to ground, logic level 0 is the lowest power, but data sheets can vary and parts can vary. So
Hmm.
you have to look at each data sheet.
Yeah. Yeah. You got to read the page 542 of the data sheet, not just the first page, folks.
Eventually, when
Yeah.
you get to the low power stuff, yes.
Yeah. Yeah. I mean, so and you mentioned kind of low hanging fruit. I mean, when you're starting to really get to the bottom of the barrel there, right? And I guess the high hanging fruit instead of the low hanging fruit rather. What are some of the things that you think about in that case? So like what are some of the things that are like the last parts of a low power design, the last things that you've been chasing in your past?
It's really varied. I mean, some of the more challenging ones that I had one case where flux residue was actually causing more current consumption than I thought.
That's a good one. Yeah.
Yeah, that was a weird one. And that was it was a little messy and sloppy on the board, and that was ended up washing the board, and it went away. So that was a weird one.
Did you mention that on Embedded FM? I think I remember hearing something about this somewhere. Maybe it was on the forum as well.
I did, yeah. So I'm not sure. I've talked about this one before because it was one of
Mm.
those. Oh my, yeah. So
That's yeah. Well, that's a story you'll tell a bunch. I mean, yeah, it's so weird, right?
it is weird. One that I've heard from people that I've never had is bypass capacitors. So
Mm.
most of the reputable brands have very good characteristics. So the thing about components, right, is there's no ideal component. So every capacitor you're getting for free a resistor, a capacitor, an inductor, another resistor. That's all built into this one device, whether you want it or not, right? So the idea though is that the resistor that goes across the capacitor should be very low, very high impedance. So there should be almost no current that goes through that. So the capacitor is really two plates and nothing that jumps
Yeah.
between them.
Right. Especially DC.
So, yeah, exactly. But it does happen. So I've heard stories of people buying particularly off-brand capacitors or just bulk source capacitors, and they've had major leakage problems for people that are doing low power design. So you do have to be concerned about that with bypass capacitors even.
Hmm. We thought we could trust the bypass capacitors. It's lurking everywhere, folks. This current is going to bite you. It's a vampire current. It'll bite you. Yeah, that's a good one. Yeah, I like that. So noticeably absent from this is like kind of, or at least from this list, maybe it is a problem though. Is like I think about like, oh well, I should go and read about the lowest power mode that all these different things. So like thinking about the ST parts, STM32s have like all the clock trees, and you can selectively power things up and down. And there's a lot of stuff, a lot of problems getting those powered up the first time, but then you can go and shut stuff off. You didn't say any of those though. Like, I mean, or is that kind of just because you're using APIs that are naturally putting them into set low power modes?
No, it's you definitely need to do that during the design phase. So what I tend to do though is think if I can, I'm lazy on power management as much as possible. The best way to make your life easy is to do something, do it quickly, and then go back to sleep. Right. So you don't
Mm-hmm.
want to be the microcontroller to be hanging around waiting for stuff or, you know, going out and doing a few sensors and then pausing and waiting for another round of sensor data while still active. So you want to have the firmware turn on, do its task, and go back to sleep. And if you can actually do that, you can make your power management thing life cycle much easier. So you can turn on everything, do your thing, and then turn off everything. And as long as everything is needed in that time, you're not really wasting much power. So you could argue that maybe if I turned off, I'm dealing with the spy sensor, for example. If I turned on the spy subsystem, did my transaction, then turned it off, I might save a little bit more power. And that's something to consider. But a lot of times that savings in that short burst is so small that it's easier just to do a single on and off for that mode. And if you have several different modes in your product, you have those different on and off segments for each mode. And that just makes your life a lot more sane. If you're really trying to get to that last bit, though, of optimization, you might have to do a little bit more.
Yeah. Yeah. I think in a best case scenario, I just put a bigger battery on there.
If you can do that, that's the easier solution.
Yeah, I think the real question, Matt, is when are batteries going to get better? Because man, they don't. Yeah, not fast enough.
They are getting better, but not fast. Yeah, there's a certain energy density that is just hard. Things tend to explode if you put too much energy in a small space.
Yeah. And now the gasoline-powered electronics.
Fusion.
Yeah, you're right. Tiny fusion bombs in our wristwatches. Yes, I remember having a hand on my right hand. uh, okay, so we've talked about the Joule scope. We talked about low power design. One thing I also wanted to talk to you about is just kind of, well, two other things actually. One would be the product design and actually the product design process, and then kind of consulting in general. I think those are both relevant things. The first being that you've been writing these really brilliant posts on the consulting forum that are just about the process of getting this thing out in the world. I mean, what are some of the struggles that you've gone through?
Yeah, it's certainly a process. So just to give a background here, I was doing consulting as more or less a solo consultant. I worked with some other people on and collaborated on some projects, but I started that back in 2011, and kind of always had my mind set on building a product someday as part of my company. And back in 2017, started being a little bit more serious about that, and settled on designing what became Joule Scope. And the advantage of being a consultant and starting this path is that you kind of already are carving out your time for different projects, right? So,
Mm-hmm.
different clients. So I carved out a little bit of time to start working on what will become my product, and treated it just like any of my other clients, although it was really the lowest priority client, right? Your paying
Right.
customers come first.
I feel like it's a double whammy because one, you're not getting paid for the work, and two, you're also giving up time that you would be, like doing otherwise. Maybe that's double counting. I don't know, but I just feel like it's a tough mental model because it's like, man, I could be making money for someone else right now.
Right. And yes, you definitely can. And cash in the bank, right, versus spending your bankroll.
Yeah, right.
But it's something that I always wanted to do. I wanted to develop my own product, so it was more
Why?
of a why.
Why is that? Yeah.
It's a good question.
Is it you've got the sickness like others who have been on the show before? Is that what it is?
Perhaps, yeah. I mean, that's definitely part of it. Part of it is that I particularly had a motivation to create something that was leveraging me as my time, and not necessarily spending it on someone else.
Ah.
Believing that I could deliver the company and the value, and it was also a great challenge for me. Something that I wanted to take the adventure of launching a product company, which there's a lot of things that go into that. I was not blind coming into it, but
Right.
I
Right.
certainly didn't necessarily know everything that was going to have to happen either.
Yeah. There's a lot of that everything else, right? I mean that's what you wrote about too. I think the marketing and the production and the shipping and all the other things that go into it. It's a lot of things that you probably didn't learn when you were going to school to become a double E, right?
Correct. Yeah. So I mean, everything from the very mundane of how do you ship things. I mean,
Yeah.
this is actually a huge problem. Shipping lots of stuff is, especially internationally, is just a pain and a nightmare. It just takes time.
Hmm.
To things like, how do you get customers, the whole marketing side of things, to production. Who do I select as my production partner when I'm not going to be building a million of something, right? I'm only going to be building a small amount. It's not worth going to Asia for manufacturing. So finding a good partner, and one of the things that I've done and I enjoy is finding small companies to partner with that they may not be the cheapest, but they focus on quality and on helping you achieve success rather than just some
Yeah.
unnameless big corporation.
Right. So you can actually get some face to face time. You can resolve issues a little easier, maybe time zone differences. A lot of the, yeah, I think a lot of the usual benefits for domestic in general are there, but with the known trade off of higher cost.
Oh, definitely. Yeah, my CM is 15 minutes up the road from me.
Oh, that's nice.
So it makes it really convenient. And JewelScope as a product is a high touch product that has a few calibration or factory test stages, including calibration, that are a little touchy. So having that closeness and knowing that they're capable, that there's one guy there that really knows what he's doing as far as this all the time, really helps me be confident that the product's being built right. So by going with that local route and exploring all the other routes as well, and then finally picking that was something I really didn't see and envision from the beginning, but it's definitely part of the process.
What? Yeah, you mentioned the calibration. I don't know if I've seen you write or talk about that much. I mean, it seems like that could be. I guess my experience with calibration was when I was at Keithley, we had like a temperature controlled room where there were a couple technicians or calibration experts that knew what they were doing basically, and they ran. They put the boxes, plugged them in, and they ran through all their cal cycles, whatever. But I guess I never really thought about actually standing up a scenario like that at a CM. What was that like?
So I designed all the test stations. So we have three different test stations that are there: a factory, programming test station, the calibration station, and then I have a final test just to make sure nothing went wrong in any of the other steps, just as a last sanity check. So just in case anything ever slipped through the cracks.
Hmm.
I had experience designing test stations for manufacturing in Asia through a prior job. So I kind of use the same mentality there. Keep it very simple: red, green, pass, fail, right and
Yep.
it's all computer based because JewelScope's computer based, and just keep it simple. But there are a lot of things with calibration that can go wrong. You know,
Yes.
I mean, JewelScope is an amazingly sensitive instrument. So when you're talking about nanoamps, really washing these boards is actually a big deal. They have to be clean and pristine, and nothing can be really wrong with them. And if there is, it's picked up in calibration. So having someone that's there that I've taught, walked through the process, taught them what's going on, and being able to troubleshoot this error means like this type of thing. So go look at the board again and see in this area. That's been was valuable. I mean, there's an operator that's less trained normally that's running it, but when things go wrong, it's good to have someone that can take control.
Does it like phone home when you have a bad unit, or is it just someone on site actually? You're basically training out the CM and technicians there to deal with what you're working with, what you have on site.
I trained out the CMs, the technician there, so
Hmm.
he's pretty much on top of everything. Every now and again, I'll get a call about something, but for the most part, they're on top of it now.
Yeah, that's great. That's like a best case scenario, I would imagine. Especially, you're a small team, right? It's you said it was you and your wife working together on this, and then some subcontractors,
Hmm.
and that's kind of it, right?
Yeah, we're going to be growing a little bit, but mostly with contractors this year for both marketing and sales and engineering as well. But yeah, we're still a small team. It's been really it's not it's kind of hard. Is it a solo effort? No, I've
Sure.
relied
Yeah.
on a lot of people, but really it's been me leading the effort along with help from
Yeah.
a number of other engineers on manufacturing, on some of the packaging. It's really weird nowadays because we rely on so many different suppliers and vendors and partners in order to produce anything, and
Yeah.
it's amazing what is available when you actually leverage the power of the world. But at the same time, someone has to get it all done too.
Yeah. Well, and then also I think links to the chain are susceptible to issues, right? So, for example, I may have been searching for a certain boost converter that's very critical to my design yesterday, and it's out in the entire world, and there's a 35-week lead time. It's like, holy crap, man! Like, but that is it's either my choices are obviously I can go design in another one, but like if I really step back and look at it, like, well, what am I going to do? Design my own boost converter like at the silicon level? No, of course not. This thing is tiny, and it's like so even just that one small thing of like leaning on a silicon manufacturer to do that function that is baked into the fabric of all these products that we're making, and it's very very interconnected. And then you start thinking about all the people stuff to just get it out the door. It's a miracle of modern commerce, I think.
It is, and I had the same problem. So I had a part that is in JewelScope that is on allocation with an advertised of 52-week plus lead time.
Oof, yikes. What kind of part?
It was a microcontroller that would not have been fun to replace. So,
Yeah, right, exactly.
fortunately, yeah, and it's just a problem with this part. And automotive manufacturers that spend way more money than I do are having problems getting this part. So, I went actually to the manufacturer and asked for some help, and they were awesome. So actually, they supplied me my pittance of microcontrollers compared to everyone else in the world.
They're like, we'll sweep the floor for you, Matt. We could find
Exactly.
these. We could find these on this floor.
But it was more than was available. So things were.
Yeah,
I sucked up the worldwide supply off Mouser and DigiKey, so
yeah,
that left no one else with stuff.
yeah. No, I think it's a weird time, man. It's a weird time for buying parts, and I think that's another thing too. Is like you're operating pretty much out of distribution, right? I'm guessing you're not putting in. Well, maybe I don't know. Maybe are you putting in like larger orders to the point where you have to do wafer starts and everything?
Not right now. So our lot size is still 500 or so.
Mm-hmm.
Well, hopefully that'll go up here, but we're with 500 you can kind of get by under the radar.
Yeah.
Our annual volume is starting to get higher, so I'm going to probably have to start managing a supply chain soon, which is a whole nother.
Yeah. That's a whole nother blog post right there.
Exactly.
Yeah.
I've been on that side of things before in my career,
Yeah.
but it's so far it's been mostly just mouse or DigiKey.
Yeah. Yep. You've mentioned subcontractors, and I've also brought that up. And I did want to call out, you were on the Hello Blink show, and I was talking to Harris and Sean recently, and they're like, oh, yeah, Matt was on like 2 months ago. I'm like, God damn it. Oh, man, he was just on. But totally different topic. So you can go and hear Matt talk about working with contractors. I thought that was a great show. What does that add or remove from the process? I mean, has it been tough for you to work in that world, or is it kind of familiar because of your consulting time and having subcontractors?
Yeah, so I have the advantage of having been a manager for a few years. So
Mm-hmm.
back in my Hillcrest days, I did a lot of the initial technology development for what became FreeSpace, but then also led a team for a few years before deciding to go off and do my consulting business. So that
Mm-hmm.
that experience certainly helps with hiring other people. It's not necessary, but it certainly does help. Now that said, I haven't been overly successful with the freelancer sites either. So
Mm-hmm. Yeah.
Upwork, Fiverr, freelancer.com. I've struggled. I've found some good things, but it's been spotty from my experience.
Yeah. Yeah. It's you can get really lucky. I got really lucky with Bilal, who I'm working with, but otherwise, yeah, I've had some duds prior to that. So
Hmm.
it's yeah, I mean, hit or miss, and I think it's just as much like if you put a job posting out there, you're going to get a lot of applications. Some are going to be, you know, perfect for the job, and some are going to be not even knowing what a microcontroller is. So like, okay, well, that's fine. Like somewhere in between is, usually you can, you just got to filter as much as you can.
And by when you run a business, there's so many things other than what you're good at that you have to do.
Yeah.
So if I look at what I can deliver with lots of value, it's the engineering side, right?
Hmm.
That's my background. I can do the management side, I can run a business, I can do marketing, I can do sales, I can do fulfillment, but really I can also find people that can do that.
Yeah.
So talking about things like everything from logo design and the getting started guide for the Joule scope insert, those are things I was easily able to go out and get someone to assist with, and they did a great job. Those are things that on the graphic side that I've had awesome luck with finding very capable people.
Yeah. Yeah. That's good. My own experience running a small business, it's like I think letting go of control is really a tough thing to do at the beginning, and
Hmm.
I think one of the remedies for me at least has just been just being so busy. I'm like, well, I can't I can't spend this time figuring out how to use Illustrator and making a shitty logo 4 times in a row and then finally handing off. I'm just going to do it from the beginning. Okay, cool, that's done.
Hmm.
Yeah.
Yeah, yeah.
So
Programmer art is not going to impress anyone.
yeah. What if I did like my initials, but like in monotype?
I hear just
Yeah.
Comic Sans is still the thing, right?
Comic Sans. Yeah, who doesn't love a good Comic Sans? Let's talk a little bit more about the hardware. You mentioned you had FPGA background, but you also do have an FPGA on board of this thing on the Joule scope. So how does that interact there? Like, what is that actually handling inside the Joule scope?
Yeah, there are actually two.
Oh, okay.
Two of the Ice 40. So the Lattice Ice 40 family is a nice history with the open source community. I'm using one that was not as favored by the open source community at the time. It's the Ultra, and there's two things that it's doing. So let me back up first. The Joule scope itself is an isolated design. So there's a very definite control side that talks to the host computer, and then there's a very definite sensor side, and those are electrically isolated through a
Mm.
transformer and decoupling for the signals that go through. On the sensor side,
So you are not going to be like my oscilloscope that's like chassis grounded that I remember in a very, very brief instant as a spark burns my retinas.
oh my gosh, how many times have I done that? Yeah,
Yeah, yeah.
exactly. So Joule scope is,
Scopes are chassis grounded, folks. Yeah, don't touch high voltage with them.
or even your 5 volt rail or 3.3 volt rail.
Yeah,
Things
right.
tend
That
to
too.
be
Yeah,
unhappy.
it can take a lot of current. Yeah, that's true. Yeah,
I don't want to admit how many times I've probably done that. So with
yeah.
Joule scope, the sensor side is completely isolated. So that side has to do two things. First of all, it has to do the measurement, and then it has to communicate the data to the other side. The FPGA that's on that side runs the ADC, runs the algorithm for auto ranging, and as of this past summer, also does the statistics computation on the instrument. So it does
Oh,
a bunch
cool.
of math. Yeah. So there's some people that didn't want to be sending back the full sample data for some of the long-term testing. They just wanted to send back the summary every two
Hmm.
hertz, and it now computes that on the FPGA.
And so the summary would be like just the current is currently or every 2 hertz. It's saying the current is 45 microamps, 47 microamps, whatever. Like that's the summary kind of data. Is that right?
Yeah. So it currently gives you the mean, min, and max.
Ah,
The
okay.
host side stuff gives you standard deviation, variance, but it was a little too much to fit into that little teeny FPGA. Variance computation requires a lot more math and stuff, and that FPGA was pretty full already. So kind of ran out of room there. So it does just the mean, min, max, and then sends that data over the isolation barrier to another FPGA that receives it. And that FPGA is really pretty dumb. It's just receiving that data and sending it over to a microcontroller, which then forwards it out over USB.
Are you using FPGAs because you wanted to have that flexibility in the algorithm side, or because you wanted to crank some crazy custom protocol that you've created?
No, it's not a crazy protocol. It's very spy-ish, but not entirely.
Oh, is it because it's one of those ADUM like isolators that's a spy based one?
No, it's just two digital lines. It's the Silicon
Got
Labs
it. Got it.
part, but yeah,
Oh yeah, yeah,
it's
yeah.
there's nothing special about that. It's just signal lines. So the FPGA there is running the ADC. So that I have two external ADCs, and it keeps them completely in sync, which is something
That's
that would be
nice.
very
Yeah.
hard with a microcontroller. It also is very responsive. So part of the challenge with an auto ranging instrument like Joule Scope is to auto range quickly. So if the target device all of a sudden jumps, like your radio turns on, right, on your ABC project, it jumps from microamps to an amp in like less than 100 microseconds probably when it turns
Hmm.
on. That amount of jump, if you don't react quickly, will cause a voltage drop, burden voltage, over the sense resistor inside Joule Scope. And if it gets too big, it would brown out your device. So this is something that's totally great about Joule Scope, is that it auto ranges in less than 1.2 microseconds, worst case, mostly under 1 microsecond. And the
Hmm.
FPGA is really helping make sure that we hit that deadline.
That's nice. Yeah, because I guess you'd have to. Well, are you doing it with like actual readings off the ADC, or are you just doing it with an overload type of scenario?
The ADC would be too slow. So we actually have
Yeah. Okay.
dedicated analog hardware that helps to
Hmm.
do that. And there's also it's more than just a threshold. We actually have an algorithm that does essentially a derivative to help
Oh,
predict
cool.
where the next thing. And this is one of the things that we filed a provisional or
Mm.
patent on.
That's sweet,
Still,
sweet IP. Yeah.
yep.
For when Keysight tries to buy him in a couple years, folks, it's because of this patent. But seriously, Keysight, buy Joule Scope. I mean, it's destroy your own margins. Why not?
Or make a bigger market. I mean, that's what we're
Or
really
yeah,
finding.
that too.
So,
Right,
I mean,
right.
the Keysight instrument and that quality of instrument with the testing that's behind it, that a name brand that's behind it, that doesn't mean it's good, but it means it's like buying IBM,
Yeah.
right? And I think
Well,
there's
yeah, and I think also if you're building it into a system, if you're building like a rack design, then it makes a ton of sense. But if it's like an isolated thing on your bench, maybe less sense.
Mhm.
Like, yeah.
Yep, and it's great to have multiple instruments so that when you come to a challenge that you don't know whether it's your device or the instrument, you can measure it with both, and you're like, "Oh yeah, it probably is my device."
Right there. It means that he is truly a double E at heart because he's saying, "I can just fix this by buying more gear."
Or
A firmware person would say, "I could fix this by writing more code or testing more code or whatever." But a hardware person says, "I can just buy more gear to test it better."
yeah,
Your true colors have been shown, Matt. It's fine.
exactly.
It's fine. You're in good company. It's a safe space here, Matt. It's fine. You're among hardware friends. We all have hardware addictions.
Yeah, surrounded by gear and eval boards.
That's right. Yeah. Well, that's great. So, are you using? So, back to FPGAs. Are you using the open tool chain, or are you using more of the vendor tools?
No, I started using the vendor tools. So the when I started JewelScope development was 3 years ago. So
Hmm.
that was the very beginning of a lot of the open source tools. They're just starting, maybe a year before that. But I went ahead and used the Lattice Ice software, which there's nothing to write home about, but it gets the job done.
Yeah. Right. I mean, honestly, that's how. I mean, like, I love the open source stuff, but yeah, people were getting FPGA designs done for a long time. They're nasty. Some of them are just like gross tool chains and IDEs and stuff, but must be doing something. They're at least outputting bit streams that work somehow. So yeah,
No, but
it's fine.
what's been happening with the open source FPGA tools have been awesome. They're now doing much faster place and route than the vendor
Yeah.
tools, and much easier, more maintainable tool set. So it's really cool.
Yeah. No, I'm really excited about it. So you'd mentioned this is on. So when we talked a little bit about it, what we were going to talk about here was FPGAs on, and you keep saying the JS110, which is the current one. That makes me think there's going to be other devices out there. What else? What else are you planning to build in the future?
Yeah, so the Joule scope as it is today is a great instrument, but you always learn something when you design a product. And there's new things that we now know that we can do to make things even better, both from lower cost, which is one approach, and also better performance. So two
Yeah.
entirely different directions. We also have some requests to make more module products. So getting all the goodness of Joule scope except as a module. So you think about products that are on the market, you can go out and buy a current sense amplifier, like pick your favorite TI INA part,
Yeah.
right?
219. Yeah.
That's it, yeah, or 190, or whatever it is, and they're great parts, but they don't do high dynamic current range,
Yeah. Yep.
right? So they have a lot of architectures that solve some of the basic current monitoring problems, like they have good CMR,
Hmm.
common mode rejection ratio, so that they can operate over the voltage and all these things that you need in order to do good, accurate measurement, but they don't have the dynamic range. What if you could up to a module that is a Joule scope module for those cases when you need it? So
Mm.
that's one potential product that's on our list, and those other both lower cost and a little bit higher performance are also on our market. We're working or on our roadmap. We're working on those now, but they're still quite a ways out. It's still very early.
Yeah.
The initial Joule scope took me over 2 years to develop. I'm hoping to cut that this time, but
Yeah. Oh, weird. Okay.
we'll see.
Yeah. Yeah, I mean, hopefully you can build on it. I mean, it seems like given your experience building these things as well, you could grab different blocks, system blocks off of the existing JS110 and then reuse it and then not have to think about it in certain ways. Like, so maybe the host side is ready to go and you just build a different sensor side or whatever that you call the other side of the isolation barrier, and you just rework it from that perspective.
There'll be some like that, but I think a lot of it is going to be redesigned. Unfortunately, I'm not enamored with the USB chip that I used, the
Mm.
USB side chip. That chip has an errata that we've worked around, but really I would not want to design it into a new product.
Mm-hmm.
So unfortunately, we can use some of the ideas and concepts and some of the code, but not the same chip. And likewise, on the sensor side, there's enough that's going to be changing that the architecture is going to be different.
Got it. Oh, okay. All right. Yeah, it's crazy how that stuff does kind of carry forward. Like, it's like you're not going to go and replace all the Joule scopes that are out there, but then you have to support multiple versions, and software kind of starts to, like, this branching tree of things that need to be supported. It's always frustrating from that perspective.
Yeah, I mean, one of the things that we have is a good definition layer for Joule scope. The software itself is architected in a way that we will be able to support multiple instruments going forward.
Oh, that's good.
Yeah, so it can be painful if you don't think about that first. We kind of thought about it. There'll be work that we need to do, obviously, but it will fit into the existing Joule scope UI and existing scripts.
What about on the scripting side? I mean, that's all Python based, but like, is there anything people should know about that side of things, of like actually writing scripts or using other people's scripts? Or
Yeah, we have examples. I mean, Python, if you're this is kind of an aside. Python is a great programming language for just putting things together. So I have my entire lab, actually, all my stuff, all scripted using Python. So I can sit at my desk and control the instruments all around with scripts or just manually, even from my computer. And that makes things really nice. And JewelScope fits into that model. Um,
I mean, have you heard about rotating desk chairs, Matt? I mean, this is just
well, if you're scripting something, right? So if you want to do a procedure on something,
yeah.
and this happens obviously with JewelScope, I do this for calibration and such, but it happens with other tests as well. If you're developing a product, you just want to do something in the same order, and if you're doing that manually, that's just a pain. And why do that when you can write a script in the same time that it would take, and now you can run it all the time?
Yeah, that's a good point. That's a good point.
So yeah, so I have all my lab equipment hooked up just through Ethernet to the computer, and it works great.
And I was going to say, and you couldn't remember GPIB though? I mean, surely some of those are talking over GPIB.
No, I have
No,
nothing
nothing.
left.
No, none of the
Nothing.
GPIB to Ethernet converters. Oh, wow. You
No.
must have fancy new equipment, not fancy 30-year-old equipment like I'm using.
I mean, even Regal stuff has Ethernet now.
Oh yeah, but that's fancy and new. I mean, like, that's got the benefit of new technology. You're not using like a Keithley 2000 DMM that was built in 1990.
Nope, don't have that.
Yeah. Mm. Well, what else should we know about the Joule Scope before we wrap up here?
Yeah, you can visit jewelscope.com, check it out, and if you have any questions, there's a contact form there on the website. JewelScope as a product was something that I started out because I had this problem a lot of times during my career of trying to measure the high dynamic current range and do low power design. So it was really designed from that need to scratch my own itch, but also make sure that it was something that's very valuable to a lot of people that are out there. So check it out, and if you have any questions, feel free to contact me.
What is the Joule Scope retail for these days?
$7.99 US
Nice. Yeah.
dollars.
You're stuck. Okay. All right.
You have a global
Shroot
audience.
Yeah, that is a good point. And you do ship everywhere, as you mentioned. Now that you've had to figure out the international shipping, it is a capability. So, are you
Yeah,
do you have distributors overseas?
we do. We have two distributors now, and we're working on joining the DigiKey marketplace as well.
Oh, cool. Okay. Yeah, that's nice. I always wondered, like, I talked to some of the DigiKey folks about that. I was like, why is this a thing, right? Like, why? But some companies, I didn't realize that some of the companies, like big companies where it's tough to get things bought, they just have like a blanket PO with DigiKey to, like, yeah, fine, whatever, buy whatever on here. It's like, oh, that makes sense then, because if I wanted to go buy a Joule Scope, it might be within the, my boss says fine, and anything under $1,000 is fine. But if I have to add Jet Perch as your company as like a vendor, that's a lot different than like I just got it on DigiKey. No big deal. So
Uh,
that makes a lot of sense.
Yep, all the whole AVL, we've gone through that with a bunch of companies, and it just takes time and is a barrier. So if you can just buy something online from a approved vendor, it just makes the whole process smoother.
Yeah. Business. Isn't business
I know.
fun? And Matt, where can people find you if they're looking to chat with you on the internets?
So I'm on Twitter, so mliberty1 at Twitter, and you can link it to my LinkedIn page in the show notes.
Okay, definitely. Cool. All right, well, thanks, Matt. I'm sure we're going to have you back on here at some point in the future so that I can ask you about my future current measurement needs or whatever the next thing you build is. So thanks for joining us.
Definitely. Well, happy to help out, and thanks for having me on the show.
All right, talk to you soon.
Bye.
While Matt's Joule Scope can help you count each slug of current and additional bundle of electrons, we're counting on our patrons to help support the show and send microphones to guests like Matt. You can join our mighty band of electronic ruffians at patreon.com/theamphour, and we'll let you into the Discourse Clubhouse.